Good morning, everyone. Welcome to today's webinar on the subject of big data marketing in the AWS cloud. We appreciate you taking your time with us today. My name is Sherry Sullivan. I'm with the AWS marketing team here in Seattle, and I'm very pleased to host this webinar today where you'll hear from AWS and MarketShare, one of our advanced consulting partners. They will share with you the experience of using AWS Cloud and share how customers are using AWS to manage big data to enable data-driven innovation. I'd like to get started this morning with a few housekeeping items. This webinar will last approximately 1 hour. We will invite you to use the Q&A tool in your browser to ask any questions during this session, and we'll take approximately 10 minutes at the end of this webinar to answer your questions today. I'd also like to let you know that today's webinar is being recorded, and we will make a link available to this presentation. You'll find us on the AWS channels on YouTube and SlideShare. Today's session, we will cover AWS, database, and big data services. We will also share with you some customer use cases and solutions. And MarketShare will provide us with cross-media analytics examples and talk about Planner. I'd like to introduce our two speakers today. John Gannon is an AWS Business Development Manager out of our New York office, and John brings over 16 years of experience in internet and software sectors. I'd also like to introduce to you Anupam Singh, the VP of Technology with MarketShare. Anupam brings over 12 years experience of leading database queries at Oracle, Sybase, and Informix, which is now IBM. So without further ado, I'd like to turn it over to John to kick us off today. Thank you.
Thanks a lot, Sherry, and thanks everyone for joining today. Really appreciate you taking the time to learn a little bit more about doing big data processing and analytics in the cloud. So what I want to do is start with a high-level overview of big data and databases on AWS. And really when we think about big data and in databases on AWS, really what I think it's all about is a set of services that are going to allow you to reduce administration, accelerate deployment, and minimize the cost of analysis and experimentation. So in a big data world, and as we're hearing more and more about big data, there are a lot of unanswered questions that organizations are trying to answer. And a lot of what the value that the AWS cloud can bring to a big data environment or a big data project is that it allows you to take that cost down tremendously of running an analysis, doing experimentation, and frankly, analyzing, experimenting with data that it perhaps just wasn't cost effective to deal with before in a more traditional kind of database environment. In terms of the services that make up most big data solutions within the AWS environment, there's 4 of them I have listed here, and I'll go into more detail on each one of them. The first one is DynamoDB. That is a NoSQL database. Relational Database Service, or RDS. This is a managed database service focused on more traditional relational databases. We'll also talk about that in a couple of slides. Elasticache, this is a Memcached compliant caching layer that sits between your database and your application or web servers, allowing you to drive additional performance and throughput. And then the last is Elastic MapReduce, and this is our Hadoop-based infrastructure service, and we'll spend quite a bit of time talking about that today as well. So let's talk about Amazon RDS, Relational Database Service. So RDS is a fully managed relational database service. It gives you a choice of database engines to run in an easy-to-deploy, easy-to-scale, reliable, and cost-effective environment. So as you can see on the left side of the slide, Relational Database Service supports multiple database technologies, and today those technologies are MySQL, Oracle, and Microsoft SQL Server. The service gives you push-button scalability for those databases, allowing you to spin up or spin down more capacity as required. And it also gives you fault tolerance, allowing you to ensure that you are able to handle failures that might occur in a given data center and be able to still make that data available to your applications and your end users. And last point that I wanted to make, this is a fully managed service, so a lot of the traditional database administrator tasks that normally you would have to go through when managing a relational database, all that is really abstracted away when you're running a relational database service. You can really focus on your data, your schemas, and your applications versus on the undifferentiated heavy lifting of actually managing database instances. So relational database service, we were talking about traditional SQL-based databases. As many of you know, there's a big movement in the industry towards new solutions that are built around non-SQL or NoSQL technologies. And Amazon Web Services has a NoSQL-based service called DynamoDB. And DynamoDB came out of quite a bit of work actually on the retail side of the Amazon business, where there were certain classes of problems that a NoSQL database was a much better fit to solve than a traditional SQL environment. And so based on those learnings and what we did on the retail side, we actually kind of expanded the scope and created a new Amazon Web Service out of that. And again, that's called DynamoDB. The key points about DynamoDB is that it's extremely fast. It's built on low latency SSDs, and it provides predictable performance with seamless scalability. So really the way this works for a developer who wants to use this service is they merely need to specify how much space they need and how much I/O performance they need, literally turning a virtual dial, if you will. And through doing that, just a few API calls, basically, allowing them to spin up a database that's virtually infinitely scalable. And we see that DynamoDB and other NoSQL technologies as well, those are often used in a big data environment closer to the end user, so almost as a sort of an edge serving environment for big data. And next I'd like to talk to you about Amazon Elastic MapReduce. So Amazon Elastic MapReduce is a managed Hadoop service running in the AWS cloud. And really the key things to think about in terms of Elastic MapReduce are that it reduces the complexity and cost of Hadoop management, number one. So Hadoop, from what we hear from a lot of our customers, and Hadoop being this NoSQL-based technology that's used to process massive amounts of data, both structured and unstructured data. What we hear from a lot of customers is that managing and the care and feeding of these Hadoop environments, standing them up, tuning them, retuning them as data needs change or analysis needs change, it's very time consuming, and it really takes away from the ability to build applications faster on top of a Hadoop type of platform. And so what we're really doing with Elastic MapReduce is we're actually taking away the management plumbing, again, the undifferentiated heavy lifting that it takes to run a Hadoop cluster, to scale a Hadoop cluster, and really let developers focus on the application and not have to worry about the underlying data processing platform. Second is that Elastic MapReduce integrates with other AWS services as well as third-party vendors. So the Hadoop ecosystem, there's more and more vendors out there now who are both vendors who have been in the market for a long time as well as new vendors who are providing interfaces into Hadoop environments. And so we have an open set of interfaces where we support integration with those third-party vendors in many cases as well. And then last, the service is highly customizable. And I point that out because the service is a managed service, and we're providing a lot of the operational support, support around scaling, fault tolerance, things like that. That's all built into the service. However, a lot of customers want to make sure that when they get that level of managed service, that they do have the ability to customize their environment, to tune it and tweak it as they like. And with Elastic MapReduce, you have the same capabilities that you would if you ran your own Hadoop distribution. So you're able to set up the same configuration parameters. You're able to tune your environment. You're actually, because you're running this in the cloud, the customization not only goes beyond it goes beyond the Hadoop configuration itself, but you actually have the ability to spin up different clusters with different hardware configurations based on the needs of your application. And that's something that customers get really excited about because it allows them to run multiple clusters simultaneously, hitting the same data set, but without causing any kind of interruption or any kind of traffic jam, which is what you would see in a traditional Hadoop environment where you have a fixed set of infrastructure and you're not able to scale that infrastructure out on demand. Elastic MapReduce, the service as a whole operated over 2 million Hadoop clusters last year, and we have a variety of customer logos here talking about some of the companies who have used Elastic MapReduce and do use Elastic MapReduce. The key point and why we talk about why so many clusters have run on our Elastic MapReduce environment is because it's given us a really great background in terms of operating Hadoop for several years, understanding the different types of data, the different data velocities, the different data flows that customers have, and really understanding at a high level how to make Hadoop run really well for a variety of different workloads. And so because we run this as a service, we're able to kind of see what works, what doesn't work, and then optimize to make sure that the platform is going to be very broadly applicable to a wide variety of different customers, use cases, and workloads. In terms of just where we sort of stand in the industry from an analyst perspective, Forrester recently indicated that we were deemed the #1 enterprise Hadoop solution. And you have the Forrester wave here with AWS in the upper right. And the selection criteria for this and why we were selected as being the leader in enterprise Hadoop is really, I think, a mix of the fact that we've run such a large number of clusters over the history of our service, which has been up for several years now, and the fact that we have seen so many different kinds of workloads and that our customers are very happy with the level of service that we provide as well as the functionality that we're providing. So I want to hand it off here to Anupam from MarketShare in just a moment. And I thought a good way to do that would be to talk a little bit about one of the case studies that we have on the AWS website related to MarketShare. And that's related to some work that MarketShare did with Ticketmaster. So Ticketmaster was looking for a real-time analytics tool to determine live event pricing during the ticket sales lifecycle. And they were trying to analyze a huge number of data sources to be able to make those pricing decisions and ultimately to generate incremental revenue for the Ticketmaster business. And so what they did, leveraging a variety of AWS services, including Amazon Elastic MapReduce, Elastic Load Balancer, and some other services, they were able to reduce infrastructure management time by about 3 hours per day per developer. And also, the solution was estimated to reduce costs by about 80% annually compared to running this kind of pricing engine within a fixed kind of static non-cloud environment. So with that, I'm going to hand it over to Anupam, and he's going to tell you about market share and some of the ways that they're leveraging Amazon Web Services big data solutions.
Hi, John. Thank you. And we will focus on market share's use of Amazon Web Services and how we were able to bring products to market at a much faster rate at a much lower cost. At the very lowest level, we are in the data management business, and our data is managed across many clusters. We provision our clusters in the most elastic possible manner, and because we run very complex data workflows, we need these workflows to be failure resistant. What we are going to talk about today is describe these characteristics with market shares applications as an example. Before we go into the technology and the architecture, let's talk about who we are and what we do. Market share brings different products for marketing analytics in the market. For media mix allocation or media resource allocation, we are the recognized industry leader. Forrester recognized us, Gartner in 2011 called us a cool vendor in that area. Over half of the Fortune 100 uses our cloud-based solutions to make the marketing more efficient or to attribute sales back to marketing spend. Now, what does that mean in terms of technology itself? Like any other enterprise application, we have a very complex workflow, and our focus is on an esoteric field in analytics, which is called modeling, where we build models which predict the effect on sales with the change in spend of marketing. So we have to, our main technical problem is to scale complex modeling. Now to do that, we have many other things to take care of. As marketing has gone into the digital era, we have started seeing customers with terabytes and terabytes of data. So an average customer would have 30 to 40 terabytes of data. As marketing has gone more complex, we also see thousands of variables describing their marketing. So a standard marketer today would be dealing with search, display, TV, radio, print, and many other marketing channels. Now, this means that we have hundreds of data sources to deal with, and of course, we have hundreds of customers. So in this environment, we had to work with a partner to build this entire pipeline at a reasonable cost, both in terms of development and in terms of operations. So let us dive a little deep into what does this mean. Like any other enterprise application, our first challenge is to just get the data into our data centers, is to bring all this data together. Today's marketing organization is faced with hundreds of data sources. So as you can see, you have social media, you have website data, you have search data, promotions, events. In this picture, pulled from one of our customers' actual experience, the advertising logs, the detailed data has to be brought in to our data center, and we have to manage incremental updates to the data at a daily level, weekly level, or monthly level. So that's the first stage. The second stage is we have to do some standard ETL with these data sources. ETL is a very well-known field, but what has changed in the last few years in marketing is that a huge amount of this data is machine generated. It is dirty and it is not ready for analytics. So every morning or every week or every month, each data source has to be scrubbed. It has to be cleaned through an ETL pipeline before we can do any analytics. So our ETL pipeline has 20 or 30 stages and hundreds of substages associated with it. So here you see an example of how our ETL pipeline looks like for one of the data sources. Our challenge is to do it for hundreds of data sources without sending costs through the roof. As in any other enterprise BI solution, most of our customers have never seen this data in a single dashboard. So the first thing that we do after we have cleaned up the data, we have brought the data into our systems, we are able to report on it. So even if it is not fully enriched with our analytics, just the fact that we are able to bring 30, 50 terabytes of data for each of our customers so that they can easily run reports, that's our first value for our customer. If you go deeper after that, most of these reports are not actionable. So just because you see a report that as a customer, your click-through rate is going down or it is going up, what do you do with it? In market share, our core technology is driven by our data scientists. We have a large team of data scientists who run models on the cloud. When the data is cleaned up, the models can run thousands of different equations and curves on this data. And most of the applications that you see today stop their usage of cloud on reporting. At market share, we believe that reporting is not enough to answer business questions. Building a predictive model is key to answering business questions. Otherwise, our users will simply get lost with the sheer number of reports that are brought up in our reporting platform. Here, we use the power of distributed systems to validate these models, to build these models, to update these models. So that's one of our key problems, technology problems, and we will look a little bit under the hood on how we have solved these problems at market share. Once the models have been prepared, they are deployed in an easy-to-use application. It should be noted that reducing big data should not mean that the user is lost. So let's say you have 30 terabytes of data and you have hundreds of reports. The user could simply be lost in those reports. Instead, at market share, we believe that the final user application to access and to analyze big data should be easy to use. And we try to hide the model's complexity and the complexity of big data by designing easy-to-use applications that are deployed in the cloud. So how does our customer access this entire pipeline? We have many applications in production. The first one is marketing efficiency, where a customer can use all the marketing data in a single system and figure out the impact of all the marketing spend to the actual sales. So this is a very complex problem for most of our customers, because when you have large enterprises running across countries and running across multiple types of products, finding where the inefficiencies are in marketing is a very intricate problem. The second application that we have in production is attribution, where the classic marketing funnel is exposed to our customers in an interactive application. So if you have $100 in sales, how much do you attribute it to paid search? How much do you attribute it to display or any other advertising medium that you have used? The third one is what John talked about, which is dynamic pricing. Again, we pull in hundreds of data sources. We use that to help our users decide the price of an event or a concert in the next week or the next wave. So these are the three applications that we have in production on top of this pipeline. Now that we know what challenges we had faced, we talked about the power of distributed systems, the power of bringing all this together. If we had tried to do this on our own, starting with buying the hardware, installing databases, installing networks, etc., we would never be able to bring these applications into the market at a reasonable cost in a reasonable time. So we decided to become one of the heaviest users and of Amazon Web Services. To make our pipeline run in the most cost-effective and timely manner, we have an architecture which uses many services from Amazon as building blocks. So our end-user application is deployed behind the Elastic Load Balancer service. So in case we get too many users at a certain time, our operations team does not have to jump in and start adding more web servers. Instead, we outsource that work to the Elastic Load Balancer service from Amazon. We also do not want to maintain our own storage because there's a large cost with dealing with maintaining the storage, removing hard disks, adding hard disks. If there is a spike in data, we would have to go into our data center and do provisioning. Instead of that, we store all our data on Amazon's managed storage that John talked about, which is, in our case, the RDS database instance, mostly MySQL, and the Amazon Simple Storage Service, which is S3. Those are the two parts of storage and scaling of the front-end application. But where do we do our data processing? When we started, all our data processing was done with Amazon EC2's permanent instances. So we would bring up a cluster, and we would use that continuously to run our data processing. As our partnership with Amazon has gone deeper, we are very big users of Amazon's on-demand EC2's Elastic MapReduce service. The Elastic MapReduce service enables us to use large number of compute power without having to maintain each one of these clusters. So in the next part of our talk, let's look at the challenges as well as the solutions on building a real-life application, a real-life enterprise-class data workflow using Amazon's Elastic MapReduce. So over the last few years, most of us have become familiar with this picture where there's a giant Hadoop cluster which has been deployed either inside Amazon or in your own private data center. So similarly, market share started 3 years ago with a very large Hadoop cluster to store all our customer data. Sometimes it would be multi-tenant, and in some cases it was not multi-tenant, and we would store for our bigger customers everything in their own private Hadoop cluster. This was running on Amazon Web Services as a very large set of EC2 instances. As we kept our applications live, as we kept executing this data workflow in Amazon Web Services, we noticed a couple of important things with this cluster. The first observation we found was that the cluster was overwhelmed for small periods. So every day between, let's say, 12 noon and 2 p.m., the cluster would become almost unresponsive because there were so many requests running on this cluster for those 2 hours. But more importantly, what we noticed was that the cluster lied unused for many hours in the day. So sometimes in some clusters we noticed that for 22 hours a day, the cluster just lay unused. Very few jobs were running, very few operations were running, and yet we had this cluster up, and we couldn't do anything about it because whenever we needed it, we needed the maximum firepower that the giant cluster could give us. So we decided to work with Amazon and figure out a solution for this. So the first step that we did was we identified all the independent data sources. So for example, in the case of Ticketmaster, we identified that concerts, sports, and events are distinct data sources. If they are distinct, then why put them on a single giant cluster? So we created Amazon EC2 instances per data source. So of course, this would mean that we would have around 100 distinct clusters running on Amazon Web Services. Now, this allowed us to run these data flows independently. So for those 2 hours, when there's a lot of jobs running, they don't run into each other. So if you're running a Hadoop MapReduce workflow for concerts, and at the same time you're running something for sports, they don't compete for the resources because they are running on different clusters. So that was our first solution, that we don't have the cluster getting completely overwhelmed during high usage periods. But what does that mean? Suddenly we had, given 100 data sources, we had up to 100 independent clusters. Now, any of us who have worked with actual data centers and actual clusters will notice that as soon as you have clusters, you have to administer them. You have to add new nodes. You have to remove some of the dead nodes. You might have to rebalance the data. You have to monitor whether the cluster is healthy every few hours. Even though technology has become better and better, data centers are becoming more and more sophisticated, we found that we would still need operations engineers to monitor these clusters. As soon as we had to add operations engineers, the cost of maintaining these clusters started going up. Not because we had high bills from our data center, but simply because somebody had to monitor these clusters for performance, for scaling, and for failures. Now that we had this problem, again we went back to Amazon Web Services and we worked with them to figure out if there is a service that could help us reduce the cost of these clusters. And what we found was the Amazon EC2 Elastic MapReduce service matched our use case. We wanted a large number of Hadoop computing power for short periods of time every morning. So what we did was we took all our different data sources, took them apart. We made them Amazon Elastic MapReduce clusters. What this meant was that these clusters would come up for a couple of hours in the morning. So let's say concerts data would be available at 8 a.m. in the morning. Around 8:15, an Amazon Elastic MapReduce cluster would come up, and it would perform the 20 or 30 ETL steps that had to be executed to finish the job. So once we had that, what we found was we were able to run this at a much lower cost. Our operations engineer did not have to worry about the size of the cluster, because the size of the cluster could be changed every morning. So let's say we saw that one of our data sources was getting too much data or it was running slow, we would be able to increase the size of the cluster very easily. We didn't have to go back to Hadoop and start running a redistribution. Instead, we would just tell Elastic MapReduce that from today onwards, we would need a cluster which is 50 nodes instead of 40 nodes. With this service, we were able to deal with larger volumes of data. We were able to change the cluster size based on historical performance, and this became a very important tool for our operations engineers to be able to dynamically provision computing power for Hadoop. But we found an important issue once we moved to this architecture. If you notice in this picture, we have 4 different clusters talking to S3 or Amazon RDS. So the first cluster is pushing data, the second cluster, third cluster are all pushing data into Amazon S3. And on the application side, another Amazon EC2 cluster is pulling that data so that it can be available to the end user of our applications. The problem with this scenario is sometimes a particular cluster could become a bottleneck. So an Amazon EC2 Elastic MapReduce service job is running slow, and that is causing the entire workflow to get stuck. So even though we've solved most of the scaling problems, the fact that one of the clusters can slow us down was a very big problem. And rerunning these jobs on a new cluster would of course mean that our operations engineer would be still kept busy, which would mean that our cost of maintaining these jobs is still high. So how did we solve this problem? MarketShare has invented a patent pending technology called pause and play, where we obsessively collect statistics for each job. So each of our stages, we collect stats like runtime, cluster size, historical time, rate of data growth, etc., etc. Given that we collect all these job stats, we are able to predict how much time should this job take. Because we have been running some workflows for over 300 days, we are able to say that a concert's data workflow should finish in 10 minutes from 8 a.m. to 8:10 a.m. in the morning. If it doesn't finish within 10 minutes, we are able to restart that job on a new cluster, or we are able to check the problems in an existing cluster. Because of this, we are able to keep all our various jobs in lockstep. We are able to synchronize the results from one to the other and continue to use 4 or 5 or 10 different clusters for a single application. So what are our lessons learned from nearly 4 or 5 years of operating our business on Amazon EC2 using all these services? The first thing we've learned is an architect for Amazon using Amazon Web Services should always think of their environment as multi-cluster. A single big Hadoop cluster is not elastic. The idea is to write configurable ETLs so that you can use multiple clusters to get the job done. If your clusters are up for the entire month, you should check on the utilization. If they are not being utilized 80% of the time, then it is better to move to an Elastic MapReduce infrastructure so that you bring up clusters only when they are needed. The second observation is that there are a lot of intermediate results. It is better to store them inside a service like S3 or RDS rather than storing them on a Hadoop cluster, because Hadoop clusters generally take up a lot of space, plus they also take up EC2 instances even though you might not be running any jobs on them. Another thing to keep in mind is compression. If you can use compression, then the low-cost storage becomes even cheaper. Lastly, what we have found is as soon as you move to a multi-cluster environment, there are many failure points that could cause your application to get stuck. It is very important to build the ability to restart directly into your architecture rather than doing it as an afterthought or doing it as a Band-Aid. So those are our lessons learned partnering with Amazon. We have been able to bring applications to market much faster. We've been able to keep our cost under control, and we have been able to scale our business as we get more and more data and more customers. With that, I would like to hand it over to John so that he can walk you through the rest of the presentation.
Thanks very much, Anupam. Appreciate the overview of how MarketShare is using AWS and our big data solutions. So I just wanted to finish up by telling you a little bit about some programs that we have to help you get started with big data on AWS. The first program we've listed here is the Big Data Discovery Workshop. This is a workshop where, based on our experience working with thousands of different customers, we will sit down with you and help you identify potential use cases where big data solutions could help you reduce cost or add additional flexibility to your analytics or data processing. The EMR Bootcamp, which is in the middle, this is a 1 to 2 day engagement where we would send one of our experts in big data technology and Elastic MapReduce to work with your team side by side to deploy a proof of concept use case using real data. So actually running production jobs or production analytics on real data sets that you have in your environment. And then the last is Elastic MapReduce training. So we're offering through one of our partners a 3-day intensive developer training for Elastic MapReduce, a deep dive where you learn how to develop applications on Elastic MapReduce, run queries on big data sets within Elastic MapReduce, as well as how to manage Elastic MapReduce clusters and tune them, etc. And those classes are being held all over the country. And the next one is actually in Los Angeles in the middle of October. We'll have one in Boston at the end of October. And then we'll go to California mid-November, Dallas in late November, and then in New York City right around the middle of December. If you're interested in learning more about those classes, we have a link there at the bottom. And those are the URL, the back end of the URL. It's AWS_EMR_training. So please feel free to check that out if you're interested, or certainly you can reach out to me if you have any questions about that or any of the other programs that we have available to help you get started with big data solutions on AWS. And with that, I'm going to turn it back over to Sherry.
Great. Thank you, John, and thank you, Anupam, for today's presentation. Very informative, and we appreciate your time. I'd like to open it up for questions from the audience. If you haven't submitted your questions yet, please do so in the Q&A tool. And we have a couple of questions to get us started. And I'll point this one back to Anupam. How do I monitor my jobs that run on Elastic MapReduce?
So in general, we use the Elastic MapReduce results that come from Amazon's service, but we've also found that there are other set of monitoring statistics that you need to collect. So, for example, how much time did it take to transfer data from S3 to HDFS, and that sometimes is a bigger failure point. We also monitor jobs on the user interface that Amazon provides. So you could log in and you could find the status. There's also a CLI that you can use to find out how far the job is along. So there are many different levels from UI to command line to your own statistic that you can use to monitor your jobs.
Great. Thank you. And John, I'll point this question in your direction, but can you speak to how Elastic MapReduce is optimized for the cloud?
Absolutely. So there's a few different areas that I'd mention in terms of how Elastic MapReduce optimizes Hadoop for a cloud environment. So as I mentioned before, Elastic MapReduce, and having the name Elastic in there implies that you have a great deal of flexibility in terms of how you provision these environments. And so with Elastic MapReduce, a couple of things you can do that really speak to that elasticity are, number one, the fact that you can grow and shrink running clusters. So one of our customers runs a 200-node cluster, and during certain times of the week, they're busier, and so they need more data processing capacity. They can actually increase the capacity of that cluster from 200 nodes to 400 nodes with just an API call and without any interruption to that cluster. And then later in the week, when they don't need that capacity anymore, they can shrink it back down again with another API call and go back down to 200 nodes. And so the great thing there is obviously they can make sure that they're meeting their users' expectations in terms of level of service, but they're also able to really map their costs to the data processing that they're doing. So when they're expanding that cluster, they're going to pay more for those additional nodes, but when they shrink it back down again, they're not going to be paying for those nodes that they decommission. Another thing I would mention is that at Amazon we always want to provide a very effective as well as a very low-cost service to our customers. And so with Elastic MapReduce, we allow you to leverage the various pricing models that we've developed in the AWS cloud. And these pricing models allow you to basically pick a pricing model that maps to your business or application requirement. So as an example, we have some customers who leverage something called spot instances when they use Elastic MapReduce. And spot instances is a way for a customer to, in essence, name their price for computing capacity, and then if they are meeting that price that's available on the spot market where other customers are also trying to get access to that capacity as well, they can actually obtain additional EC2 instances to run in the Elastic MapReduce cluster, but do it at a highly discounted price from what they would normally pay if they were running these EC2 instances on demand. And so that flexibility and that integration there with these different pricing models to help customers reduce costs but not actually have to worry about managing that within their application, I think that's a big value as well.
Great. That helps clarify. Thank you, John. And one additional question, and Anupam, I'll direct this to you, but can you clarify the biggest difference between the relational and the non-SQL databases?
So what we have found out is that it is very important to map the nature of your data processing or your database to the actual use case. So for example, we have found that 70 to 80% of our usage on Hadoop is through the Hive query tool, not, let's say, HBase or not native MapReduce workflows. We started by writing our own native MapReduce code, but we have steadily moved to a SQL type of interaction with our Hadoop clusters. In most cases, the non-SQL databases are used as a tool, an infrastructure component as the backend for applications. So let's say you need a very interactive application and you are very clear about what the data access patterns will be. In those cases, we use non-SQL databases. But for our overall workflow, we still use SQL very heavily. In terms of specifically introducing DynamoDB, our lessons in using DynamoDB is, as I said, is one, you should be very sure that your use case is not SQL, and you should use DynamoDB in those cases. Secondly, DynamoDB is better when you know the data access patterns very clearly so that you're able to access without writing rich queries. So if you wanted to look up user profiles, DynamoDB would be great. But if you wanted to sum across 10 terabytes of data with some other table being joined, in that case, you're better off using SQL.
Great. Thank you for sharing that insight. So if there are no other questions from attendees today, I'd like to thank everyone for their time, especially for John and Anupam. Thank you for taking time to provide us with a great overview today. We will make this recording available for on demand. Again, thank you for joining us. We appreciate your time, and we look forward to you joining our next webinar.